Welcome to you all in this course on fluid mechanics. In the last class, we discussed about some vector identities. We discussed some vector integral theorem and orthogonal curvilinear coordinates and the arc length of in the orthogonal curvilinear coordinate system. Now in this lecture, we shall discuss the gradient of a scalar field, the divergence of a vector field, and the curl of a vector field and in an orthogonal curvilinear coordinate system. So let us start. Firstly, we shall discuss the gradient of a scalar function in orthogonal curvilinear coordinate system. So suppose phi be a continuously differentiable scalar function, and this phi is the function of orthogonal curvilinear coordinates u1, u2 and u3. So I am supposing that this grad of phi is vector k1 e1 plus k2 e2 plus k3 e3, where e1, e2 and e3 are unit vectors along the curvilinear coordinates, and k1, k2, k3 are some scalars, and this one we shall determine later on. Suppose R be the position vector of a point P in the space, then dr. So dr we can write as dou r by dou u1 du1 plus dou r by dou u2 du2 and dou r by dou u3 du3, and dou r by dou u1 we are writing as h1 e1, dou r by dou u2 we are writing as h2 e2, and dou r by dou u3 we are writing as h3 e3. So therefore dr is equal to h1 unit vector e1 du1 plus h2 unit vector e2 du2 plus h3 unit vector e3 du3. Now d phi, so d phi is equal to grad phi dot dr. So we shall take the dot product of equations 1 and 2. So when we shall take the dot product, we shall get k1 h1 du1 plus k2 h2 du2 plus k3 h3 du3. But d phi is equal to dou phi by dou u1 du1 plus dou phi by dou u2 du2 plus dou phi by dou u3 du3. Now we shall compare this equation 3 and 4. So from equations 3 and 4, what we shall get? We shall get k1 h1 is equal to dou phi by dou u1, k2 h2 is equal to dou phi by dou u2, and k3 h3 is equal to dou phi by dou u3. So from there we shall get, since k1 h1 is equal to dou phi by dou u1, so k1 is equal to 1 by h1 dou phi by dou u1. Now since k2 h2 is equal to dou phi by dou u2, so therefore k2 is equal to 1 by h2 dou phi by dou u2, and since k3 h3 is equal to dou phi by dou u3, so therefore we shall get k3 is equal to 1 by h3 dou phi by dou u3. Now we shall put this value of the constants scalars k1 k2 k3 in equation 1, because we want to determine these scalars k1 k2 k3. So when we shall put this one into the equation 1, we shall get grad phi is equal to 1 by h1 dou phi by dou u1 unit vector e1 plus 1 by h2 dou phi by dou u2 into unit vector e2 plus 1 by h3 dou phi by dou u3 into e3. So therefore grad phi is equal to, suppose phi I am writing outside, e1 by h1 dou by dou u1 plus e2 by h2 dou by dou u2 plus e3 by h3 dou by dou u3 to phi. So we shall compare. Then this nebula operator is equal to e1 by h1 dou by dou u1 plus e2 by h2 dou by dou u2 plus e3 unit vector e3 by h3 dou by dou u3. Now if phi is equal to u1, then grade of u1, so grade of u1 we shall put here phi is equal to u1, then you will shall get e1 by h1 dou u1 by dou u1, which is 1, and here we shall get e2 by h2 dou u1 by dou u2, which is becomes the 0, and e3 by h3 dou u1 by u3, so this is also 0, so last two term will be 0, we shall get e1 by h1. In the same way, if phi is equal to u2, we shall get grade u2 is equal to e2 by h2, and if phi is equal to u3, then we shall get grad u3 is equal to s e3 by unit vector e3 by s3. Now if we shall replace this unit vector e1 by h1 by grad u1, unit vector e2 by h2 is equal to grad u2, and unit vector e3 by s3 by grad u3 in equation 7, then we shall get grad phi is equal to dou phi by dou u1. You see from here, dou phi by dou u1 grad u1 plus dou phi by dou u2 grad u2 plus dou phi by dou u3 grad u3. So these are the different form of grad phi. So grad phi we obtained as equation number 6, we obtained as equation number 7, and this is also one of the form of the grad u, which we shall later use on many of the derivations. So now we shall discuss the divergence of a uniform vector function in orthogonal curvilinear coordinates. So suppose f be a continuously differentiable vector function, and this f is the function of the orthogonal curvilinear coordinates u1, u2, u3, and suppose the component of this vector f is f1, f2 and f3 along the coordinate axis, those along which the unit vectors are e1, e2 and e3. So this vector f is expressed as f1 e1 plus f2 e2 plus f3 e3. Okay, here this e1 unit vector e1, e2 and e3 are the unit vectors along the curvilinear coordinate axis. Now equation 9 can be also written as, since we know that this unit vector e1 is the cross product of unit vector e2 and e3. So e2 cross e2, e2 cross e3 is equal to e1. Unit vector e2 is equal to e3 cross e1, and unit vector e3 is e1 cross e2. So what in this equation 9, e1 unit vector e1 is replaced by e2 cross e3, unit vector e2 is replaced by e3 cross e1, and unit vector e3 is replaced by e1 cross e2. So equation 9 assume the form of equation number 10. Now just we have derived that grad u1, here we have derived grad u1 is equal to e1 by h1, grad u2 is equal to e2 by h2, and grad u3 is e3 by h3. So from here we can get this unit vector e1. Unit vector e1 is h1 grad u1, unit vector e2 is h2 grad u2, and unit vector e3 is h3 grad u3. So e1 is h1 grad u1, e2 is h2 grad u2, and e3 is h3 grad u3. Now in equation 10, that e1, e2 and e3 is replaced by h1 grad u1 plus h2 grad u2 and h3 grad u3. So when we shall use equation 11 in equation 10, then we shall get the vector f is equal to f1 h2 h3 grad u2 cross grad u3 plus f2 h1 h3 grad u3 cross grad u1 and f3 h1 h2 grad u1 cross grad u2. Now we have to find out the divergence of this vector f. So divergence of f is equal to divergence of this vector f1 h2 h3 grad u1 grad u2 cross grad u3 plus divergence of f2 h1 h3 grad u3 cross grad u1 plus divergence of f3 h1 h2 grad u1 cross grad u2. So divergence of f is expressed as sum of the divergence of these three terms. So that is expressed in equation number 13. So I am going to calculate just this first term, and in the same way we can write the second and third. Same way we shall calculate the second and third. So first I have calculated divergence of f1 h2 h3 grad u2 cross grad u3. So f1 h2 h3, this is a scalar, and grad u2 cross grad u3 is the cross product of two vectors. So this one is a divergence of a scalar function phi into a vector. So this one is how we are expressing. We shall take from the vector identities what we discussed in the earlier class. So f1 h2 h3 divergence of grad u2 cross grad u3 plus grad of f1 h2 h3 dot grad u2 cross grad u3. Now this one we shall write as it is f1 h2 h3 divergence of cross product of two vector. So that one can be expressed, that vector identity we shall use here, grad u2 dot curl of grad u2 minus grad u2 dot curl of grad u3 plus grad of f1 h2 h3 dot grad u2 cross grad u3. So you see here this term curl of grad is 0, so this term is 0, and curl of grad u3 is also 0 because curl of grad of a scalar function is 0. So these two terms will be 0, so this whole first term will be 0, so we shall get, and here since dot product is commutative, so I have written grad u2 cross grad u3 dot. Now this is the multiplication of three functions. So this is grad of f1 h2 h3. So f1 h2 h3 is a scalar function, so grad of phi. So we shall use the derived formula grad of scalar function phi. Just we have derived this formula. Grad of phi is equal to dou phi by dou u1 grad u1 plus dou phi by dou u2 grad u2 plus dou phi by dou u3 grad u3. So this formula we shall use here. So we can write dou by dou u1 of f1 h2 h3 grad u1 plus dou by dou u2 of f1 h2 h3 grad u2 plus dou by dou u3 of f1 h2 h3 grad u3. So this term we shall get. Now this term, this is a scalar, okay, and this grad u1, this is a vector, so overall this is a vector. Grad, this term is again a scalar, and grad u2, that is a vector, and this term is a scalar, and grad u3, that is a vector. So we shall use the scalar triple product formula. So if we shall take this dot product here, then we shall get grad u2 cross grad u3, and this one I am writing first. So grad u1 dou by dou u1 of f1 h2 h3 plus same way you can write grad u2 cross grad u3 dot grad u2 into dou by dou u2 f1 h2 h3 plus grad u2 cross grad u3 dot grad u3 dou by dou u3 of f1 h2 h3, but last two term will be 0 by the property of scalar triple product, grad u2 cross grad u3 dot grad u2. So this vector is since repeated, grad u2 is repeated, that's why it is 0. Same way grad u2 cross grad u3 dot grad u3 is 0 because this grad u3 is repeated. This is the property of scalar triple product. So that's why this last two terms will be 0, and we shall get grad u2 cross grad u3 dot grad u2 dou by dou u2 of f1 h2 h3. So what I am doing here, I am just dividing this whole equation by 1 by h1 h2 h3, means I am dividing by h1 h2 h3. So I will multiply here by h1 h2 h3. So in this one I am multiplying by h2, this one I am multiplying by grad u3, I am multiplying by h3, and grad u1 I am multiplying by h1. Okay, so 1 by h1 h2 h3 dou by dou u1 of f1 h2 h3, and we know that this one h1 grad u2 is equal to e2, h3 grad u3 is equal to unit vector e3, and h1 grad u1 is the unit vector a1. So we shall get e3 cross e2 cross e3 dot e1, and e2 cross unit vector e2 cross unit vector e3, that is e1 unit vector, and e1 dot e1 is 1. So we shall get finally 1 by h1 h2 h3 dou by dou u1 of f1 h2 h3. So this is the first term of the divergence of the vector f. By same way these two terms will be calculated. So just I express those two terms. The first term is divergence of f1 h2 h3 grad u2 cross grad u3 is 1 by h1 h2 h3 dou by dou u1 of f1 h2 h3. Similarly, divergence of f2 h1 h3 grad u3 cross grad u1 is equal to 1 by h1 h2 h3 dou by dou u2 of f2 h3 h1, and same way divergence of F3 H1 H2 grad U1 cross grad U2 is equal to 1 by H1 H2 S3 dou by dou U3 of F3 H1 H2. So we shall use these results, equations 14, 15, 16 to the equation number 13, means we shall add all these three. So when we shall add, then we shall get divergence of F is equal to del dot F, which is equal to, so 1 by H1 H2 S3 is common, so 1 by H1 H2 S3 dou by dou U1 of F1 H2 S3 plus dou by dou U2 of F2 S3 H1 plus dou by dou U3 of F3 H1 H2. So this is the divergence of a vector field in orthogonal curvilinear coordinate system. Okay, now finally we shall find out the curl. So we shall find out the curl of a uniform vector function in orthogonal curvilinear coordinates. So suppose f be a continuously differentiable vector function of the orthogonal curvilinear coordinates u1, u2 and u3, and suppose that the component of this unit this vector f is f1, f2, f3, then this vector f can be expressed as vector f is equal to f1 e1 plus f2 unit vector e2 plus f3 unit vector e3, where e1, e2 and e3 are unit vectors along the curvilinear coordinate axis. Now this one we know already derived. Unit vector e1 is equal to h1 grad u1 plus unit vector e2 is equal to h2 grad u2 plus unit vector E3 is equal to S3 grad U3. Now we shall use equation number 19 to the equation number 18. We shall replace this unit vector E1 by H1 grad U1. We shall replace this unit vector E2 by H2 grad U2, and we shall replace this unit vector S3 by E3 by S3 grad U3. So when we shall use, then we shall get vector f is equal to f1 h1 grad u1 plus f2 h2 grad u2 plus f3 h3 grad u3. Now we shall take curl of f. So curl of f is equal to Nebula operator cross f, which is equal to curl of the first vector f1 h1 grad u1 plus curl of this vector f2 h2 grad u2 plus curl of the vector f3 h3 grad u3. So I will solve the first term, and same way we shall write the same way we can determine the next two terms. So firstly we shall do the first term. So curl of f1 h1 grad u1. So this is the curl of f1 h1, that is a scalar, and grad u1 is a vector. So this is the scalar product of a scalar f1 h1 to a vector grad u2. So by the property of vector, by the vector identities, we can write this one as grad of f1 h1 cross grad u1 plus f1 h1 curl of grad u1. So curl of grad u1 is 0 because curl of we have already seen that vector identity. So this term will be 0. So we shall get grad of f1 h1 cross grad u1. Now grad of a scalar function f1 h1 is a scalar function. So just we have derived the gradient of a scalar in orthogonal curvilinear coordinates. So we shall get dou by dou u1 of f1 h1 grad u1 plus dou by dou u2 of f1 h1 grad u2 plus dou by dou u3 of f1 h1 grad u3 cross grad u1. Now we can write, so this is a scalar, so we can write dou by dou u2 this term, this first term we can write dou by dou u1 of f1 h1 grad u1 cross grad u1. So we know that the cross product of same vector is 0, so this first term will be 0. Now second term, dou by dou u2 of f1 h1 grad u2 cross grad u1, which is written here. Dou by dou u3 of f1 h1 grad u3 cross grad u1, which is written here. Now what I had done, I multiplied here by h1 h2 and divided by h1 h2, and h1 h2 I taken with grad u2 and h1 I taken with grad u1. So h2 grad u2 is written as e2 unit vector e2, and h1 grad u1 is written as unit vector e1. So this first term become 1 by h1 h2 dou by dou u2 of f1 h1 e2 cross e1. Same way this one we can write. We have divided and multiplied here by h1 h3, and H3 I written with grad U3 and H1 I written with grad U1. So this is H1 grad U3 cross S3 grad U3 cross H1 grad U1. So this is E3 cross E1. So I can write 1 by H1 S3 dou by dou U3 of F1 H1 unit vector E3 cross E1. So since here unit vector E2 cross E1, that is E3 minus E3. So here it is negative sign. So this is minus 1 by H2 dou by dou U2 of F1 H1 unit vector E3 plus E3 cross E1 is E2. So I used here 1 by H1 S3 dou by dou U3 of F1 H1 E2. So therefore curl of H1 F1 grad U1 is equal to unit vector E2 by S3 H1 dou by dou U3 of F1 H1 minus unit vector E3 divided by H1 H2 dou uh, uh, dou by dou U2 of H1 F1. So this one is the first term of 21, equation 21 I calculated. The remaining term can be calculated by the same way. So I am writing those expressions. Curl of F1 H1 grad E1 is unit vector E2 by S3 H1 dou by dou U3 of H1 F1 minus E3 unit vector by H1 H2 dou by dou U2 of H1 F1 curl of F2 H2 grad U2, which is equal to unit vector E3 by H1 H2 dou by dou U1 of H2 F2 minus unit vector E1 by H2 S3 dou by dou U3 of S2 F2 and curl of F3 S3 grad U3 is equal to unit vector E1 by H1 S3 dou by dou U2 of S3 F3 minus unit vector E2 divided by S3 H1 dou by dou U1 of S3 F3. Now we shall use this equation 22, 23 and 24 into the equation number 21. When we shall use this equation into that equation number 21, then we shall express those summation in terms of a determinant. Then we can write as curl of f is equal to 1 by h1 h2 h3. So what I here it is done. Here it is multiplied by h2. So this is h2 e2, and here we divided by h2. In the same way we shall do for here we shall multiply by h3. Here we divide by h3. With all this term we shall do, and we shall take common 1 by h1 h2 h3. So we shall get 1 by h1 h2 h3 determinant with the first row h1 unit vector e1, h2 unit vector e2, h3 unit vector e3. Second row dou by dou u1, dou by dou u2, dou by dou u3, and third row is h1 f1, h2 f2, and h3 f3. So this is the curl of the vector f. So in this lecture we discussed three things. First one is the gradient of a scalar function. Second, we have discussed the divergence of a vector function and curl of a vector function. Okay, in next class we shall discuss some special kind of orthogonal curvilinear coordinate system. Particularly we shall discuss the Cartesian coordinate system and cylindrical coordinate system, as well as further we shall discuss the spherical polar coordinate system. Firstly, we shall show that those coordinate system are orthogonal curvilinear coordinate system. Then we shall discuss those system. We shall find out the gradient, divergence and curl of vectors in those orthogonal curvilinear coordinate system. We shall also find out the arc length, the sides of the elementary parallel piped, surface areas and volume of the elementary parallel piped in those systems. So thank you very much for attending.